So one more problem to look at here. Sometimes I want to find the second derivative of a function. So we could call that y double prime, we could call that d squared y dx squared. And I can do that even if that first step through has to be through implicit differentiation. So for this example, I have an equation that defines the relationship between x and y, 2x cubed minus 3y squared equals 7. I want to find the second derivative of y with respect to x. Just like if this were an explicit function, I'm going to start by finding the first derivative. So I'm going to start by finding dy dx. So my plan here is to take the derivative of both sides with respect to x. The derivative of 2x cubed with respect to x is 6x squared minus the derivative of 3y squared with respect to y is 6y, and I'm going to multiply by dy dx. If you like, feel free to use y prime here. I'm just going to do this problem with primes instead of dy dx just to show you it's a little less writing, to show you that's an option. So that's 6y times y prime equals the derivative of 7 with respect to anything is 0. So my first step, I want to isolate dy dx. In this case, I called it y prime. I'm going to subtract 6x squared from both sides. I'll get negative 6y times y prime is negative 6x squared. Divide both sides, that was a y prime, by negative 6y. And I get y prime equals, I have negative 6x squared over negative 6y. The negative 6's will cancel. And I got x squared over y. So that's my first job. I found y prime, and it's equal to x squared divided by y. So here's my first step. I found y prime. I found dy dx, and it's equal to x squared over y. The big picture, I'm trying to find the second derivative. I'm trying to find y double prime, or d squared y dx squared. So how do I go from here? To find the derivative of y prime, which is what I need to do. I need to take the derivative of the derivative. So I need to take the derivative of x squared over y. Notice that x squared over y is a quotient. So to take the derivative, which I'm going to call y double prime, I'm going to use the quotient rule. It's going to be low, which is y, times d high, which would be 2x, minus high is x squared, over d low. So think about what that means. I need to take the derivative of y, but I'm taking the derivative with respect to x. So the derivative of y with respect to x is called dy dx, or we called it y prime. Either one is fine. So that's low d high minus high d low all over low squared. So this is going to be y squared. Just to clarify, that's a square. There's a little bouncy square there. Square. Now this is pretty good. This is an expression for the second derivative, y double prime, or d squared y dx squared. But just notice that this expression, y prime, it's kind of like a variable. And since our original problem only had x's and y's, we don't want to give an answer that has another variable in it. So what we're going to do is we're going to take the y prime expression that we got in our first step and just substitute it in. So this would be my final answer. Y double prime is going to equal y times 2x. I'm going to call that 2xy minus x squared times x squared over y all over y squared. Now if you simplified this, maybe got a common denominator here, fine, but not required. So this is an excellent answer for y double prime. 2xy minus x to the fourth over y all over y squared.